All right, today we're going to talk about the idea of multiplying integers. And one concept that will be helpful to remember is where the idea, how to model that idea of multiplying. So let's just say, I'm going to throw this up at the top of the page real quick. Let's just say I have 2 times 4. Okay, so that means 2 times 4. That means there's a couple ways I could look at it, but I'll just look at it this way. That means I have 4 2 times. So I have 2 groups of 4. Okay. Well, some of you say, well, yeah, I've got 2 groups of 4, and that makes sense. Or you could say, well, yeah, but don't we have 4 groups of 2? Absolutely, we have 4 groups of 2. And no matter how we look at that, that's going to be 8. Now, I say that because this is going to be a concept that is going to help a little bit just to remember where multiplication is coming from. Okay, so here we go. We are going to be looking at using repeated addition to find 3 times 2. Recall that multiplication is repeated addition. 3 times 2 means 3 groups of 2. Okay, so I'm looking at that and I'm seeing, okay, so we get 3 times 2. I've got 2 tiles and I have 3 groups of that. Well, that's pretty easy. I count those tiles, I look at that, and I say, oh, okay, well, that has to be 6. So I say 6. And that kind of makes sense. It's 3 groups of 2. You add them up, it's going to be 6. Or you could know that the math fact is 3 times 2 is 6. Now, how do we model that on a number line? Well, the way we're going to do that is we're going to use a vector, an arrow, and the arrow is going to be the length of 2. Because this problem is saying 3 times 2. So it's saying I've got 3 groups of 2. So, oops. Okay, so let's see if I can get this. Okay, so that means that I'm going to have that 3 times 1, 2, oops, 3. And if I do this right, which is a little bit off, but if I do this right and I stack up 3 arrows of 2, then it is going to be 6. And so that's how you'd model that on a number line. You get 3 arrows that are a length of 2, and it ends up being at 6. So, and that's kind of helpful to see. So what happens then if I have 3 times negative 2? So now we're throwing the integers in. Okay. So the first thing I'm going to say is that we still have one thing that's the same on this problem from the last problem is we still have 3 groups. It's 3 groups, but it's 3 groups of negative 2. So how that would look different with the tiles is that it would look like this. I have 3 groups of negative 2. Well, that seems kind of easy. It's just negative 6 because they're all red. Okay, so I'm going to have negative 6. So I look at that, and that's pretty straightforward. So I'm going to try this a little bit differently here. So we've got 3 groups of negative 2. So on the number line, that would be like 3 arrows that are the length of 2, but they're all going in the negative direction. So negative 2, negative 2, negative 2, and we end up at negative 6. And so that's how that goes. Okay. And so that kind of makes sense too when you think about it. So I have a positive number in the front, so I have 1 positive and 1 negative. And because, we could look at that, it ends up in the negative direction. Okay. Now there's another way to look at this. So what happens if I've got negative 3 times 2? What if my front number, which we've been saying is the number of groups, is a negative and the other one's a positive? Now, there's another way to build this concept, okay? So let's just look at that, all right? And then we could look at a different way to look at it. All right, so we're just going to look at, since it's negative 3 times 2, let's just look at the multiples of 2. So 2 times 2, 4. 1 times 2, 2. 0 times 2, 0. So what you're noticing here is that we're decreasing by 2 every time we go down. So we follow those patterns in. If I continue to decrease by 2, 4 minus 2 is 2. 2 minus 2 is 0. 0 minus 2 is negative 2. Negative 2 minus 2 is negative 4. And we just keep following that pattern down. So we see that even though it's the front number that is negative, which typically is the number of groups that we have a negative number of groups of a positive number, we're still going to end up at negative 6. Okay? And so it's just in both of these scenarios, one of the values. So this scenario up here, one of the values was negative 2. This scenario down here, one of the values was negative. So one of the values was negative, our result was negative. Now, another way you could look at this, honestly, is to take a look at the commutative property. The commutative property says I can change the order and it doesn't change the problem. So we could call this 2 times negative 3. And then I've just got 2 groups of negative 3, right? So I've got 1, 2, 3, 1, 2, 3. It's negative 6. So many different ways to look at this. So many different ways to model this. We could do the number line where we have, which I didn't draw a number line on this one, but you guys will get the idea. So this is negative 3, and we've got 2 of them. So negative 3. So if we're starting at 0, this is going to be negative 6. Okay, so many different ways to model this, but the idea is that if one of the values is negative, then the result is going to be negative. Okay, so let's go ahead and take a look down here at what happens then when we have 2 negatives. So we're going to follow the pattern here. Right? The modeling is a little bit different on this because tiles, I have negative 3 groups of negative 2. Like, how do you do that, right? Okay, so what we're going to do here is we're going to look at that same pattern in the table. Okay, so we just figured out that if I have one of them is going to be negative, then it is going to end up being a negative product. So negative 3 times 3. So negative 3 times 3 is negative 9. Negative 3 times 2 is negative 6. And it seems kind of it's going down, but really in the negatives. So we're really adding 3 here. Negative 3 times 1 is negative 3. So we added 3 here. So if we follow that pattern of adding 3, negative 3 plus 3 is going to be 0. Negative, and then so forth and so on. So I'm adding 3. So negative 9 plus 3 is negative 6. Negative 6 plus 3 is negative 3. Negative 3 plus 3 is 0. 0 plus 3 is 3. 3 plus 3 is 6. And so what we're seeing here then is that when we do this, if I end up with negative, so both of them are negative, we end up back in the positives. It's like saying the opposite of the opposite. You end up back where you started. Okay, so if I have the opposite of a negative, and that's how negative signs can be read. It's just saying it's the opposite. So if I have the opposite of 3 times the opposite of negative 2, or the opposite of 2, that's going to cancel each other out. Okay, so that ends up being positive 6. This is going to be 6 right here. Okay, so it's kind of an interesting pattern. Okay, I'm going to write over here. So negative 3 times negative 2. So it's basically saying the opposite of negative 2. That's positive 2. 3 groups of that. And it's kind of weird. I don't know. But it's a rule that you can learn. So you're like, I'm not sure. I mean, the table kind of makes sense, but I'm not sure I really know that. It is still going to be a rule that you need to remember that if I have the same sign right here, the result is going to be positive. And if I look up here, if I have different signs, the result is going to be negative. Okay, same sign, positive, different sign, negative. And these are multiplication rules, so don't start applying these back at addition. It doesn't work that way. All right, so the type of product, so same sign, positive. They're both positive. So same sign, positive. Number 6, different signs. So type of product. I messed that up. Okay, so this is same. This is different. This is different. This is same because it's negative and negative. It's the same. They're both positive. This is different. Positive, negative. This is different. Negative, positive. This is same. Okay. Well, what is the product? 3 times 2 is 6. 3 times negative 2 is, well, 3 times 2 is 6, but it's a different sign, so we know it's going to be negative. So that's going to be negative. So the product here is plus. They were same. The product there is going to be negative because they were different. We did this one that was different. It was negative 6, and it was negative. Oh, negative, negative. That was the same, and it ended up being positive 6, so it's positive. Oh, same. That 6 times 3 is 18, so we know that one's going to be positive. 2 times negative 5. Oh, that's different. There's 2 groups of negative 5, which would be negative 10. That was negative, different sign, negative. And 6 groups, negative 6 groups of 5, or 5 groups of negative 6, that's going to be negative 30. Negative. And we got same sign, but they're both negative. So we followed that pattern in the table and figured out that's actually going to be positive. Okay. And so this table should really illustrate that when it's the same sign, it's positive. Same positive, same positive, same positive. When it's different sign, it's going to be negative. So different, negative, different, negative, different, negative, different, negative. And so that's all this table is doing, is developing that pattern and showing you that rule. Okay, so when you're multiplying things that have the same sign, the result will be positive. When you're multiplying things that have different signs, the result's going to be negative. And that's the gist of what we're going to do today. And you're going to do some problems along that line, but just practicing and knowing that rule and how to do that. Okay, thank you. Ask questions and work hard.